Welcome to Astronomy Daily, your daily dose of space and astronomy news. Today, we're going to explore some big developments in space exploration and research. We'll be diving into SpaceX's latest lunar mission that's carrying both a private lander and a NASA orbiter to hunt for water on the moon. We'll also look at Australia's historic preparations for their first orbital launch attempt and discover how NASA technologies are revolutionizing life here on Earth. Plus, we'll explore some fascinating new findings about mysterious dwarf galaxies, check in on NASA's Lucy spacecraft as it approaches its next asteroid target, and uncover new insights into some of the most magnetic objects in our universe, Magnetars. Let's get started with today's space news. In a spectacular sunset launch from NASA's Kennedy Space Center, SpaceX's Falcon 9 rocket successfully carried two lunar-bound spacecraft into space. The primary payload, the Athena lunar lander built by Intuitive Machines, is now on its way to explore the moon's South Pole region in search of water ice deposits. This marks Intuitive Machines' second mission to the moon, following their historic first landing earlier this month. Athena carries 10 NASA science instruments, with its main package being Prime 1, which includes a drill called Trident that can reach 3 feet below the lunar surface, and a mass spectrometer to analyze the collected samples for water and other compounds. But Athena isn't traveling alone. The mission also includes an innovative hopper robot named Grace that will explore nearby craters through a series of controlled jumps, and a small rover called MAP that will test the moon's first cellular network. These tools will work together to study areas that have remained largely unexplored, including permanently shadowed craters where scientists believe significant deposits of water ice may exist. Sharing the ride is NASA's Lunar Trailblazer orbiter, which will map water ice deposits from lunar orbit, complementing Athena's ground-based observations. This coordinated approach will give scientists an unprecedented view of lunar water resources, critical for NASA's Artemis program and future human settlements on the moon. The mission represents a significant step forward in commercial NASA partnerships, with Intuitive Machines leading the way in delivering scientific payloads to the lunar surface. If successful, Athena will touch down in the Mons Mouton region, where it will operate for about 10 Earth days, gathering crucial data about potential resources that could support future lunar missions and potentially even sustain human presence on the moon. Next up, one for our listeners down under. Australia is about to mark a historic milestone in its space exploration journey. Gilmour Space, an Australian company that's been developing rocket technology since 2015, has announced its first orbital launch attempt scheduled for March 15th from the Bowen Orbital Spaceport in northern Queensland. Their rocket, named Eris, stands an impressive 82 feet tall and represents years of Australian innovation and engineering. This 3-stage hybrid propulsion rocket is designed to carry payloads of up to 474 pounds to a sun-synchronous orbit 310 miles above Earth's surface. After securing the necessary approvals from Australia's Civil Aviation Safety Authority late last year, the company is now ready to attempt this groundbreaking launch. CEO Adam Gilmour has been careful to manage expectations, noting that first launches are notoriously challenging. Even SpaceX needed 4 attempts before achieving its first successful orbital launch. The team emphasizes that whether they make it off the pad, reach maximum aerodynamic pressure, or achieve orbit, every second of flight will provide valuable data to improve future launches. With more than 200 employees and backing from various private investors and superannuation funds, Gilmour Space has grown from a small startup to a significant player in Australia's emerging space sector. The company isn't just focused on rockets. They're also developing satellite platforms with the ultimate goal of making space access more affordable. While the team remains optimistic, they acknowledge that various factors, including weather conditions and technical issues, could lead to delays. Safety remains their top priority, and they've made it clear they'll only proceed with the launch when all conditions are optimal. If successful, this mission will mark the first time an Australian-designed and built rocket reaches orbit from Australian soil, opening a new chapter in the country's space exploration history. And may we be reporting that Australia has a happy Gilmour shortly. Sorry, I couldn't resist. Let's take a look now at some of the great work NASA's been doing. NASA's latest spin-off publication has revealed some remarkable ways that space technology is revolutionizing life here on Earth. For nearly 25 years of supporting astronauts in low Earth orbit, NASA has developed technologies that are now finding incredible applications in our daily lives. One of the most fascinating developments involves a platform that allows commercial industries to conduct space station experiments. Scientists have successfully grown higher quality human heart tissue, knee cartilage, and pharmaceutical crystals that can be used to develop new medical treatments right here on Earth. The innovation doesn't stop at medical breakthroughs. Remember those challenges of watering plants in zero gravity? The solution NASA developed has evolved into electrostatic sprayer technology, now being used in sanitation, agriculture, and food safety. And those specialized treadmills designed to keep astronauts fit in space, they've been adapted into anti-gravity treadmills that are helping people with various conditions exercise more effectively. Even the nutritional supplements originally created to keep astronauts healthy during long space missions are now available for everyday use. But perhaps most exciting are the developments in construction technology. Companies are using NASA's 3D printing techniques, initially designed for building structures on the moon, to print large buildings here on Earth. There's even research into growing buildings from fungus, a concept first explored for lunar construction that's now being adapted for Earth-based housing. Quality control systems on assembly lines are getting smarter thanks to artificial intelligence originally developed to help rovers navigate Mars. And in the energy sector, NASA's expertise in liquid hydrogen rocket fuel is helping pave the way for hydrogen-based energy solutions. With over 40 NASA-originated technologies now in commercial use and more in development, these space-age innovations are quietly transforming industries and improving lives across our planet. Astronomers have recently made a fascinating discovery about the universe's smallest and faintest galaxies, known as ultra-diffuse galaxies, or UDGs. While studying 30 of these mysterious cosmic entities in the Hydra Galaxy cluster, located more than 160 million light-years from Earth, researchers found something completely unexpected about how these galaxies move. About half of the UDGs they observed showed peculiar rotational patterns in their stars, movements that simply don't align with our current theories about how these faint galaxies form and evolve. This discovery is particularly significant because these galaxies have only been known to science since 2015, and they've been puzzling astronomers ever since with their unusually elongated shapes and ultra-faint nature. The research team made these observations using the MUSE integral field spectrograph on the Very Large Telescope in Chile. One UDG in particular, designated as UDG 32, proved especially interesting. This dwarf galaxy was found at the end of a gas filament connected to a much larger spiral galaxy called NGC 3314A. What makes this finding so intriguing is that UDG 32's location doesn't appear to be mere coincidence. The stars in UDG 32 are younger than those in other UDGs in the cluster, yet surprisingly they contain more heavy elements, or metals in astronomical terms. This suggests these stars formed from gas and dust that was originally part of the larger neighboring galaxy, supporting the theory that some UDGs might form when gas is pulled away from larger galaxies through gravitational interactions. These findings are more than just interesting space facts. They're helping us piece together the complex puzzle of how galaxies form and evolve. The research team's results have effectively doubled our knowledge of these mysterious galaxies, providing the first comprehensive view of how these faint systems exist within a still-forming galaxy cluster. It's a reminder that even in our modern age of astronomy, the universe still has plenty of surprises in store for us. Lucy, NASA's ambitious asteroid-exploring spacecraft, has just reached an exciting milestone in its mission by capturing its first images of asteroid Donald Johanson, currently appearing as just a tiny point of light 45 million miles away. This 2-mile-wide space rock will be Lucy's next close encounter, scheduled for an April 20th flyby at a distance of just 596 miles. This upcoming visit follows Lucy's fascinating encounter last November with asteroid Dinkinesh and its companion, moon Salam, which turned out to be quite the surprising duo. Salam revealed itself to be what scientists call a contact binary, essentially two separate objects touching each other, held together by their mutual gravitational pull. The origin of this unusual pairing remains a mystery, though researchers suspect Salam might have formed from material ejected from Dinkinesh due to the effects of solar heating over millions of years. While Donald Johanson currently appears as nothing more than a distant speck, Lucy won't get a detailed look at the asteroid's features until the day of the close approach. But this encounter is just one stop on Lucy's packed itinerary. In 2027, the spacecraft will reach its first Trojan asteroid, Eurybates, which sits in a vast swarm of asteroids sharing Jupiter's orbit. After visiting several more Trojans, Lucy will swing back by Earth in 2030 for a gravitational boost before heading to explore even more of these ancient solar system remnants. Interestingly, the asteroid Donald Johanson's name has a direct connection to Lucy's own. It honors Donald Johanson, the paleoanthropologist who discovered the famous 3.2 million-year-old human ancestor fossil, nicknamed Lucy. Just as that ancient skeleton helps us understand human evolution, the asteroids Lucy is studying are like fossils from our solar system's birth, offering crucial clues about how our cosmic neighborhood came to be. To wrap things up today, in a fascinating new study published in Nature Astronomy, scientists have finally begun to unravel one of astronomy's most perplexing mysteries: how magnetars generate their incredibly powerful magnetic fields. These extraordinary neutron stars have magnetic fields up to 1,000 times stronger than typical neutron stars, which are already among the most magnetic objects we know of. The breakthrough came from studying what scientists call low-field magnetars. These cosmic oddities present an interesting puzzle because while their baseline magnetic fields are relatively weak, they somehow manage to produce intense bursts of X-rays and gamma rays that should require much stronger magnetic fields. Through detailed computer simulations, researchers have identified a likely culprit, a process known as the Taylor-Sprout dynamo. This dynamo effect occurs because of the way these stars rotate. Unlike a solid object spinning uniformly, different parts of these stars rotate at slightly different speeds. This differential rotation, particularly strong in their cores, creates the conditions needed to amplify magnetic fields to extraordinary levels. The process appears to be kicked off during the violent supernova that creates the magnetar, when angular momentum is transferred into the core of the dying star. For low-field magnetars specifically, this mechanism explains how they can temporarily boost their magnetic field strength to produce those powerful radiation bursts we observe. It's a different story from traditional magnetars, which likely generate their consistently strong fields through other means. This discovery not only helps us understand these extreme objects better, but also provides crucial insights into the complex physics at play in some of the universe's most extreme environments. And that's all for today's episode of Astronomy Daily. Thanks for joining me on this cosmic journey through the latest developments in space exploration and astronomical discoveries. I'm Anna, and if you want to stay up to date with all the latest space and astronomy news, head over to astronomydaily.io, where we have a constantly updating newsfeed and all our previous episodes available for listening. You can also join our growing community across social media. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, and TikTok. Until next time, keep looking up and wondering about the mysteries of our universe. See you tomorrow.